Hello, my name is Dr. Michael Forster from Implexx Sense, and today I'm going to show you how you can quickly and easily convert the raw temperature data from an Implexx Sap Flow Sensor into sap flux density and total sap flow. So we'll be going quite quickly today, so if I am too quick or if you're looking for further information, just jump on the Implexx website and go up here to the More and the Manuals and Guides drop-down menu. And you can see here there's a whole bunch of manuals and guides with definitions and steps and tips and what have you for what we're going through today. There's also another menu here, another web page here, the statistics and analysis. So there's a whole range of some other great information there on how you can convert your sap flow data and do some stats and analysis. Okay, so here is the Implexx Sap Flow dashboard in the Excel file. So when you first open it up, it will be set to these default settings. So we want to import our actual measured data from our tree. So over here we have an instructions tab. So here we've got step-by-step outlining exactly how to do this. And if you scroll further down, there's also a whole bunch of information on equations and the steps we take to go through our conversions. And further down, there's the published references or the published literature, which we are referring to here. So all the information there is on the instructions tab. So the next tab to go to is the raw data. And when you open that up for the first time, there's just some default settings. So we want to import our raw data from our Implexx Sap Flow Sensor. So on the raw data tab, you'll notice there are a series of columns, the date and time, the alpha, beta, and Tmax, as well as the outer and inner positions. So it is really important that when you copy and paste or import data into these columns, that you match this format exactly. So here is our file that we have downloaded from our data logger. So as you can see here, the columns line up exactly in the dashboard file as well. So I'm just going to copy and paste that over. And it's all copied and pasted over. So click on the dashboard worksheet. And this has now updated to the actual measured data that we can see on our tree. So down here on the time slicer, we can expand that out so we can view our entire data set there. So here we've got the entire season where from the start of the year through the summer into the autumn and when there are no more leaves on the tree. And you can also zoom in this little drop-down menu here. You can zoom into, say, different quarters. So if you want to look at more closely at the start of the season, you can zoom in, or you can scroll along and look at, say, during the summertime, what is going on there. Or you can even look at different months as well. So you can zoom into, say, February, for example. So this slicer here is a great way to zoom in and out of your data set very quickly. Okay, so the first thing that you will notice with our raw data is we have these spikes here and also some negative values here. So we want to go through and update our settings and correct for these errors here, so we have a nice clean data set. So to do that, it's quite easy. So you look at this table up here, the whole bunch of parameters. And again, if these parameters are new to you or you are unsure of what the definition is, just jump over to the Implexx website and go to the Manuals and Guides webpage where you can find all this information. So the most important thing you need to understand about this table is the units of measurement. So that is given in this column here, and it is really important that you obey these units of measurement. So you can see here they're in centimeters and grams and centimeters cubed. So if you start inputting data as inches or millimeters or meters or pounds or ounces or kilograms or some other unit, it's going to cause errors in the calculations and your data will be inaccurate. So it's really important that you observe the units of measurement here exactly. So the first thing we want to do is update our wound diameter. So for our particular tree, it was 0.2, so we'll just leave it there. The sapwood wet weight, we measured 1.1 grams. For the sapwood dry weight, we measured 0.61 grams. For the sapwood wet volume, we measured 0.864 grams. And you might have noticed there that the density, the dry density of the sapwood was updating automatically. So you can leave that to update automatically, or you can enter that value yourself. The trunk diameter for our tree was 17.7 centimeters. The bark depth was 0.5 and the sapwood depth was 3.5. So we'll leave that as it is. So we've updated our tree parameters there. So that's all good to go. But you'll still notice on our graphs over here that we have some spikes in the data, and the inner position is showing some negative values. So what is causing this is a thing called probe misalignment. And for detailed information on probe misalignment, again, just jump over to the Implexx website. You can see here there's a link here for correction for probe misalignment. So there's a whole lot of good information on that link there about what is probe misalignment. So first of all, let's correct for the probe misalignment in the outer downstream for the top graph here. So to do that, what you want to do is put in a large value just to add an extreme, and let's see how that changes the data. So we changed it from 0.6 centimeters to 0.7. And as you can see here, that hasn't quite corrected the data as we'd like. We've actually caused some more spikes, so that has caused more errors. So that is not the correct distance between the heater and the downstream outer temperature sensor. So let's change that to 0.65 and let's see if that is a better number for us. And we can see there that it is now looking much better. We don't have the spikes. So let's jump over to the second half of the data set, and that is also looking quite nice over there as well. So 0.65 is a good number for the distance between the heater and the outer downstream measurement point. So let's do the inner downstream. So we're now looking at this graph down the bottom here. So let's again try an extreme example of 0.7. Let's see how that changes our data, and that has actually made it a lot worse. So you can see here there's a lot of spikes and a lot of noise in the data, so that's not what we want at all. So let's try 0.65. And that is updating our graph, and you can still, it's looking slightly better, but still it's not good enough. There's still a lot of noise. And if I zoom in on that, you could see that quite clearly. So if I zoom in onto January, for example, so you can see there, you can see up the top here, the data looks exactly how Sap Flow data should look like, but down the bottom here, it's looking quite messy. So let's just change that back to the default setting of 0.6. And it's actually looking pretty good there. So for this one, there probably wasn't any probe misalignment. So let's just leave it at 0.6. But as you can see down the bottom here, we're seeing some negative values during the nighttime. So that is still there's still an offset in our sensors there. So we want to correct for that as well. So let's just zoom back out to a larger view. So let's go back to the beginning of the data set where we have this zero flow condition here. So with the downstream sensor, the outer position, you can see there's a slight positive when it should be zero. So let's just adjust that. Again, let's choose and as you can see there, it's gone below zero. So we've gone a bit too far there. So let's readjust that number. And there we go. So that is updated nicely there. And let's do the bottom data set. So let's go for a higher number here. Let's see how that, and that's actually made it more negative there. So that's not quite correct. So let's go the other way. Let's go a number below 0.65. And you can see here it's now above zero. So that's not quite correct either. So let's just adjust that slightly. And there we go. We can see there that it's now sitting on zero. So if we just zoom back out to the whole year there, so we can see up there it's looking quite nice. And over here in December, we've got sort of some rainy periods, and you can see there the values are down on 0, which is what we want to see. And let's look at the second half of the season, and very nice, it's down on 0 as well. So we've now corrected our data set. This is all ready to go. We've done all the tree properties, we've done the probe misalignment. So this data set has been corrected, and it's now ready for statistical analysis and further comparison. So if we scroll further down the page, you can also see a graph for the total sap flow. So if we zoom out to the entire season of the data set there, so you can see quite nicely here, there's 0 total sap flow at the start of the year when there are no leaves on the tree, and at the end of the year as well, when the leaves are during the autumn or during the fall, the leaves are falling off and going back down to 0. And in the middle of the season, in the summertime, here in the southern hemisphere, we've got about 40 to 50 litres a day of total tree water use. So that's a great way just to see a summary of what your tree is doing. Okay, to export the data, so here it is, we've got the next tab along, the sap flux density, and you could use these data here, but there's a whole bunch of calculations going on behind the scenes here. So what I like to do is just highlight these data, copy that data, open a new Excel file, and if I paste that directly from there, you can see it's still in the table format, which is not quite what we want. So let's just close that down. So let's try that again. So what we want is go up here to paste, and then paste special, and then this option here, the values and number formats. So select that and click OK. And you can see here that the date and timestamp has copied and pasted, and our data from the outer position, the sap flux density in the outer and the sap flux density in the inner, has pasted over quite nicely. So the next tab along is the total sap flow. So let's just copy and paste that over as well. So let's open a new worksheet, and again paste special, values and number formats, and OK. And so this is total sap flow in litres per hour, and all our numbers are there as well. So all our data has been corrected. We've fixed the probe misalignment, and in our new worksheet, all the data is ready to go for further statistical analysis.